This is the test review guide video answer key for Pre-Calc Unit 4, which is trig inverses and solving trig equations. So the first thing that you're going to need to be able to do is recognize the graphs of both the sine, cosine, and tangent regular function graphs, as well as the inverse graphs. And remember that we're going to give you the graphs of all 6 with the restricted domains and ranges. So take a look at these 6 graphs that I have here, and let's start with sine. And the key that I would say to remembering which graph is which is to start by looking at the domains and ranges of the graphs. So for example, in the regular sine function, when I say regular, I mean the one that's not the inverse, your domain is going to be from negative 90 to positive 90, but that will also be inclusive of negative 90 and positive 90. And you can see that in your x values of the graph. And then your range is going to be from negative 1 to positive 1. And again, that will be inclusive, and you can see that in the y values of the graph. Remember also that when you are talking about an inverse function, and remember that we can write sine as sine to the negative 1 or arc sine, and both of those mean the inverse of the sine function. When you're talking about an inverse function, those the domain and range will exchange, which is the function of an inverse. An inverse switches the x and the y, or the domain and range, or the input and the output. And so your domain of the inverse function will be negative 1 to positive 1 inclusive, and the range of the inverse sine will be negative 90 to positive 90, and again, that is inclusive. Now, when you're talking about cosine, remember that cosine is the problem child. So the cosine that's not inverse, when we restrict the domain and range, the x values are going to go from 0 to 180, again inclusive, 0 to 180. And then your range, just like the sine, is going to go from negative 1 to positive 1, inclusive. And once again, for the inverse functions, cosine inverse with a negative 1 or arc cosine, you're going to exchange that domain and range. And so now your domain is going to be negative 1 to positive 1. And your range is going to be the 0 to pi. So there's sine and cos. With tangent, it's going to behave a little bit more like sine than cosine. Although remember, with tangent, you've got the situation where you have all real numbers. So if you look at your original graph of the tangent function, the tangent that's not inverse, remember that you have asymptotes at positive and negative 90, and your domain literally goes from there to there, from the asymptote to asymptote. And because they're asymptotes, and so the graph of the function never actually touches those asymptotes, your domain goes from negative 90 to positive 90, but it's not inclusive. So you're going to use those round parentheses instead of the square brackets. But your range, and this is important, and I couldn't find a graph online that would show this, but you remember that your range goes up and down to positive and negative infinity. So that's going to keep going because it doesn't cross over into the restricted domain. And so our range is going to be all real numbers, negative infinity to positive infinity. And then when you exchange the domain and range, or you reflect the graph of the original tangent function across the line y equals x to get the inverse or the arctan function, that the part of the graph that's continuous to positive and negative infinity is now the domain. And so you've got these arrows here that show that the graph goes forever left and forever right. And so your domain for the inverse tangent is going to be negative infinity to positive infinity. But those asymptotes that had been vertical asymptotes now for your inverse graph, they're going to be horizontal asymptotes, again at positive and negative 90, and therefore your range here is going to be positive and negative 90, but not inclusive. So if you truly understand the idea of inverse, you understand that it exchanges the input and the output. And so normally, when we first learned about trig functions, we learned that we would take the sine, cosine, or tangent of an angle, and so the angle is the input, and then we get an answer that is a ratio of two of the sides of the triangle. And so when we are talking about an inverse, we want to exchange the input and the output. And so in this case, the inverse trig function is going to have an input that's the ratio of the sides, and the output, or the answer to your equation, is going to be the angle itself. So here's what I'm talking about. If you look at this triangle in number 1A, the angle we're looking at is theta, and I've highlighted that. But then the sides that we're looking at are the adjacent side and the hypotenuse. So if you want to mark that, you could say that this is the adjacent and this is the hypotenuse. And we know that the trig function that deals with adjacent and hypotenuse is cosine. But this time, instead of saying cosine of theta, the directions ask you to use an inverse trig function. And so we want to talk about cosine inverse. And therefore, our input has to be the ratio adjacent over hypotenuse, which is going to be 4 over x. And our output is the theta. And again, in 1b, if we're talking about the angle theta here, then the sides that we have to consider are the place where x plus 1 is the opposite side, and the place where I have the 10 is the adjacent side, and we're talking about opposite the angle and adjacent to the angle. And the trig function that we have that deals with opposite and adjacent is tangent. So instead of saying tangent of an angle or tangent of theta, we're going to say tangent inverse or inverse tangent of, and then we want the input to be the ratio of the two sides. And so that'll be opposite over adjacent, or x plus 1 over 10, and the output to be the angle, which is theta. Now, in numbers 2, 3, and 4, what I want you to do is look at what's happening to each sine, cosine, and tangent in the different quadrants, or based on whether I give you a positive or a negative input, is your answer going to be in the first, second, third, or fourth quadrants. And you'll have to review the pictures of the graphs and the restricted domains and ranges from the first page of this packet in order to truly understand the why behind each of these. But it would help you to remember that sine and tangent behave mostly the same. So if you can kind of keep in mind, sine and tangent behave mostly the same, and cosine, and I've joked about cosine being the problem child, but cosine is the one that's going to behave differently. But having said all of that, all three, sine, cosine, and tangent, if the input is positive, your answer is in the first quadrant. So inverse sine of 1/2 is 30. Inverse cosine of radical 3 over 2 is 30. And inverse tangent of radical 3 over 3 is 30. All three of those positive inputs give you a first quadrant angle. But now when I look at negative inputs, the inverse sine of a negative input and the inverse tangent of a negative input both give you a fourth quadrant angle. But a negative input with cosine gives you a second quadrant angle. And so in this case, and remember also, to interrupt myself, when I say fourth quadrant, I know that you understand enough about the trig to know that if the domain and range, if the restricted range of the inverse function is from negative 90 to positive 90, that's first and fourth quadrant. Just remember that 30, negative 30 in the fourth quadrant is going to be written as a negative angle, and it's not going to be positive 330, it's going to be negative 30. So when you write the fourth quadrant angle for sine inverse or for tangent inverse, you're going to write negative and then a fourth quadrant angle, not positive big number fourth quadrant angle. So negative 30, negative 30. But for cosine, when you're thinking about the restricted range for the inverse cosine, that is going to take you into the second quadrant, and your it's hard to see that, but your restricted range for the inverse cosine is from 0 to 180, and so those angles can be bigger than 90, and so you're going to use the answer 150 degrees, which is your reference angle in the second, or your angle in the second quadrant that has the reference angle of 30. So as far as making a comment, really this section is just for you to make a note to yourself of how to remember that. And so for myself, I'm going to just put a little note here that for positive inputs, and of course the context is talking about inverse functions, and so I'm not going to say that, but positive inputs into the inverse trig functions give a first quadrant answer. And that for negative inputs, and now I have to delineate, let me change colors here. So for negative inputs, sine and tangent inverse, let's say sine inverse and tangent inverse, have fourth quadrant answers, but cosine inverse has a second quadrant answer. And notice that I did the cosine with red because it's the problem child. So please use and refer to this chart here, 2, 3, and 4, as a reminder that the cosine with the negative input is the one that has the potential to be confusing. Now, in number 5, this is straight practice with using the inverse functions for computation. And so I'm just going to kind of talk you quickly through these. Inverse tangent or arctangent of 1, when the input is 1 for tangent, remember that you're asking yourself tangent of what angle would give you 1. Because 1 is a positive number, we're talking about the first quadrant, and so your answer will be 45 degrees. Please don't forget to put the degree symbol, and if you'd rather give radians, you're welcome to give radians. My answers will be in degrees on this video. Remember that for sine and tangent, when your input is negative, you're going to give a negative fourth quadrant angle, and therefore, if it were positive, radical 2 over 2, inverse sine would be 45. Since it's negative, radical 2 over 2, your answer is going to be negative 45 degrees. Neither sine nor cosine has the number 3 in the range of the inverse function. And so for part C, sine inverse of 3, well, sine inverse can't be 3. 3 can't be an input to sine inverse, and so we're going to say that this is undefined. For part D, positive input into cosine inverse will behave the same in the first quadrant as sine and tangent, and so your answer is going to be a first quadrant answer, and you'll get 30 degrees here. Now, the angle that makes sine equal to 1 is a quadrantal angle, which means that you need to kind of be thinking about your 1s and 0s. Now, when I say think about your 1s and 0s, really what I'm talking about is that if you were to kind of reference the unit circle, and just the places where the unit circle crosses the x and y axes, you think about all those 0s and 1s or negative 1s. All the x values are cosines, all the y values are sines. And so sine is 1 right up here, and that's 90 degrees. And so your answer to inverse sine of 1 is going to be 90 degrees. If I were you, I might just draw this on the front of my test or somewhere on a scratch paper or something while I'm taking my test, because I would need to come back to that regularly. Now, in letter F, we have an example of a negative input into inverse cosine. And remember that when your input into inverse cosine is negative, your answer is going to be a second quadrant angle. And so if it were positive radical 2 over 2, inverse cosine of positive radical 2 over 2 would be 45. So you need to be thinking of 45 as the reference angle. But in the second quadrant, 45 is going to be the angle 135. And you might want to just put a little star or highlight this problem, that it's behaving differently than some of the other problems. In letter G, you're asking yourself what angle would make sine equal to 1/2. So sine inverse of 1/2 is 30 degrees. In letter H, again, you have a negative input into inverse tangent, which means that your answer is going to be a negative angle in the fourth quadrant. And so if it were inverse tangent of positive radical 3 over 3, your answer would be positive 30. And so in this case, your angle's going, or your answer is going to be negative 30 degrees. In letter J, again, you have a negative input into inverse cosine, and so your answer is going to be a second quadrant angle. If it were inverse cosine of positive 1/2, your answer would be 60. And so what you need to do is consider where is inverse cosine, where is 60 degrees in the second quadrant, and the reference angle is 60. So the answer here is going to be 120 degrees in the second quadrant. Now, inverse cosine of -1, again, I'm going to think about my ones and zeros. And if you look closely at the x values, then your x value at 180 is going to be -1. Cosines are your x values there, and so your answer to this problem is 180 degrees. Arctangent of radical 3, tangent of 60 equals radical 3, and so inverse tangent of radical 3 is 60 degrees. Arctangent of 0, again, if you're looking at your ones and zeros, remember that tangent is sine over cosine. The 0 is your sine, the 1 is your cosine, and 0 over 1 equals 0. And so arctangent of 0 is 0 degrees. Sine, inverse sine is -1, and that's where your y value is -1. So looking back at the one I drew for the problem 2 steps above, it's this one. And so your answer for inverse sine of -1 is going to be not 270. Be careful, because it looks like where we have been saying 270, but remember that the range of inverse sine is -90 to +90. 270 doesn't happen between -90 and +90. We have to use -90 as the answer, which is a coterminal angle to 270. Arc cosine of 5 over 3. If you were to divide on a calculator 5 divided by 3, you get one. You actually get 1.67, and so you've got a number that's bigger than 1. And remember that you can't have an input into inverse sine or cosine that's bigger than 1. And so your answer for letter R is undefined. Remember that tangent of +1 is 45. So inverse tangent of -1 is going to be -45. Inverse sine of negative radical 3 over 2. Well, sine of +60 is positive radical 3 over 2, so inverse sine of negative radical 3 over 2 is going to be -60 degrees. Now, when you're doing composition of functions, remember that you want to work from the inside out. Sorry, drinking coffee at the same time as I'm making a video. So the first thing that you want to consider is the inverse cosine of radical 3 over 2. So I'm going to ignore the sine for a minute, that sign at the beginning of the problem. I'm going to look at inverse cosine of radical 3 over 2. Inverse cosine of radical 3 over 2 is 30. And so this question is actually asking me, what is the sine of 30? Now, when we're just talking about sine, not inverse sine, we go back to our unrestricted domains and ranges, and that doesn't really affect this problem, but just keep that in mind. Your answer here is 1/2. In part B, also everything's in the first quadrant, and so when I do part B, I'm starting with what is the inverse sine of 1/2. Inverse sine of 1/2, interestingly, from the previous problem, we know that it is 30 degrees. And so this problem is asking, what is the cosine of 30 degrees? Cosine of 30 degrees is radical 3 over 2. Now let's start looking at some other quadrants. The answer to inverse tangent of -1 is negative 45 degrees. And then the cosine of negative 45 degrees does not have any restricted domain or range because it's just cosine, it's not inverse cosine. Negative 45 is a fourth quadrant angle. Cosine is positive in the fourth quadrant, and so your answer to this is going to be radical 2 over 2. Here, if you look at inverse cosine of negative 7 over 9, that's a negative input into the inverse cosine. Negative input into inverse cosine means that you're going to be thinking about a quadrant 2 angle. And cosine of a quadrant 2 angle is going to be a negative answer. And so the angle that gives you 7/9 when you plug it into cosine is the number that goes here, that angle. There's your theta. And so your answer is going to be negative 7/9. Letter E, the input is positive. Everything's in the first quadrant. And so the inverse sine of radical 2 over 2 is 45 degrees. And this question is asking you, what is the tangent of 45 degrees? Tangent of 45 degrees is 1. Now, F gets a little bit tricky. You can track with it. The sine of 7 pi over 6 is asking you for the sine of an angle that is in the third quadrant. Think 7 pi over 6. Well, 6 pi over 6 would be 180. So 7 pi over 6 would be a third quadrant angle. And because all sad turtles cry, we know that sine in the third quadrant is negative. So your answer to this is going to be negative. And so, excuse me, the reference angle is 30 when the denominator is 6, right? Reference angle is 30 degrees. And so sine of 30 is 1/2. Sine of 7 pi over 6 is going to be negative 1/2. And so this question is asking, what is the inverse cosine of negative 1/2? Now, that becomes a second quadrant problem because inverse cosine of a negative means that your answer has to be a second quadrant answer. If it were inverse cosine of positive 1/2, it would be 60. And in the second quadrant, 60 is the reference angle for 120 degrees. And so your answer here is 120 degrees. Letter G. I don't know anything about angles that have a denominator of 7, but I can tell you that pi over 7 is a first quadrant angle. Tangent is positive in the first quadrant. Inverse tangent of a positive number is positive in the first quadrant, and so inverse tangent of the tangent of a positive angle is going to be the same input and output. Here again we have inverse cosine of a negative input. So your answer just to the inside function is going to be a second quadrant angle. Remember that this is going to be a second quadrant angle, so quadrant 2. If it were positive radical 2 over 2, it would be 45 degrees. 45 in the second quadrant is 135. So this question is really asking you, what is the tangent of 135 degrees? Tangent in the second quadrant is negative, and so the tangent of 135 degrees is going to be -1. So the next 4 problems, J through N, are very similar to the previous page. They just didn't fit. If you have the sign, I used the wrong color and you can't see it. I use the sine inverse, tan inverse of the first or fourth quadrants. Your input is your answer. Don't stress out about that. It's not going to be a massive portion of your test. But if you think this through, if you look at just the inside function, sine inverse of a negative puts you in the fourth quadrant. Sine is negative in the fourth quadrant, and so you're going to come right back to the same answer as your input. So this is going to be -1 over 13. It's when you start getting into cosine or other quadrants that you have a function and its inverse of each other that you start getting into different answers. Now, tangent of pi over 4, well, pi over 4 is 45, and so tangent of 45 is 1. And so this problem is asking you, what is the cosine inverse of 1? And that's going to be a quadrantal angle. And if you think about your 1s and 0s, right here, the x values are the cosines, and so cosine of 0 degrees is 1, so inverse cosine of 1 is 0 degrees. So like I said 2 problems ago, it's when you start to getting into cosine and other quadrants that you have to really take the problem apart and think about it. So let's start with cosine of 7 pi over 4. When we're not talking about the inverse function, we're not looking at any kind of restrictions on the domain and range. 7 pi over 4 is in the fourth quadrant. So the angle 7 pi over 4 is a quadrant 4 angle. Cosine is positive in the fourth quadrant. 7 pi over 4 has a reference angle of pi over 4, or 45 degrees. And so the cosine of 45 degrees is radical 2 over 2, and in the fourth quadrant it's positive. So this problem is asking, what is the inverse cosine of positive radical 2 over 2? Well, that's going to take you back to the first quadrant, and so it's just going to be 45 degrees. In letter N, when you start with the inside function, 3 pi over 4, that's like asking about the cosine of pi over 4 in the second quadrant. 3 pi over 4 is a second quadrant angle. And cosine is negative in the second quadrant. All sad turtles cry. Only sine and cosecant are positive in the second quadrant. So cosine of 3 pi over 4 is going to be negative radical 2 over 2. And so this problem is asking, what is the arc sine of negative radical 2 over 2? Arc sine of a negative gives you a negative answer in the fourth quadrant, so this is going to be negative 45 degrees. Now, before we start talking about the next 3 problems, I want you to compare the inputs for each of those problems to the inputs of the previous problems within number 6. So the previous 4 problems on this page and the problems at the bottom of the last page. And recognize that, well, I hope that you can recognize that all of the problems that we've done so far have dealt with special angles or inputs that give you special angles. And in these 3 problems, 4 over 3, 5 over 13, 3 over 8, none of these have anything to do with any kind of special angles. And so for these 3 problems, you're going to need to draw triangles that will help you find the values of the composition. So if you have inverse tangent of a negative input, remember that means that you're looking at a fourth quadrant angle. And so I'm going to draw a fourth quadrant triangle. Remember that when you draw a triangle in a particular quadrant, that you put the angle that you're talking about, or the theta, near the origin. The right angle goes on the x-axis. Tangent is opposite over adjacent, and in the fourth quadrant the y value is negative, so in this case the 4 is negative. I hope you recognize that this is a 3, 4, 5 right triangle. If you don't, you can do the Pythagorean theorem and find that 5, but it might be more helpful to you time-wise to remember 3, 4, 5 always goes together. And then if the answer to this entire input right here is theta, that whole thing is theta, this question is really asking, what is the sine of theta? We'll go back to the triangle to look at anything about theta. And in this case, the sine of theta opposite over hypotenuse is going to be negative 4 over 5. In letter R, we have a positive input into cosine. And a positive input means that we're going to have a first quadrant triangle. And so a first quadrant triangle is going to look like this. Theta near the origin, right angle on the x-axis. Cosine is adjacent over hypotenuse, and the opposite side is 12. If the answer to arc cosine is theta, this question is asking what is the tangent of theta, and this triangle, the tangent of theta is 12 over 5. In letter S, we are again given a negative input into sine or tangent, and so this is going to be a fourth quadrant triangle. Sine is opposite over hypotenuse, so 3 over 8, and in the fourth quadrant, the y value is negative. And just to step back a second, in letter P, you had a triangle that was a 3, 4, 5 right triangle. In letter R, you had a triangle that was a 5, 12, 13 triangle. Those are both Pythagorean triples with all whole numbers. But in letter S here, there's no Pythagorean triple with whole numbers that will give you 3 and 8, and so you're going to need to do the Pythagorean theorem. So a squared plus b squared equals c squared. So let's call a squared the side that we're looking for. Negative 3 squared is 9. And the hypotenuse squared, remember c always has to be the hypotenuse. The hypotenuse squared is 64. Subtract 9 from 64 and you get 55. So a squared equals 55. And then the square root of a squared is a. A equals radical 55. And so this third side of the triangle is going to be radical 55. Now again, the answer to this is theta. And so this problem is asking us what is the cosine of theta based on this triangle here. The cosine of theta will be radical 55 over 8. Now, if you need to pause the video and grab your formula sheet, make sure that you find your formula sheet. Remember, I'll give you a clean copy of the formula sheet for the test. And so on your formula sheet, you want to look for the sum and difference identities and the double angle identities for the next 4 problems. Now, when you look at these problems, you should recognize that you have sine inverse, which gives you an angle, and I'm going to call that angle alpha, and it gives you cosine inverse, which also will have an answer that's an angle. I'm going to change highlighters, which I don't think you can see me doing. Cosine inverse of a negative input, and that's going to give you another angle, and so we're going to call that angle beta. And so what I want to do here is draw 2 different triangles. I'm going to draw one triangle that goes with alpha and one triangle that goes with beta. I'm going to do that over here. And so alpha, I'm going to do that work in pink. Sine inverse of a negative input is a 4th quadrant triangle. And so that triangle is going to look like this. This time, instead of theta, I have to write alpha. And it's sine inverse of negative 3 over 5. So the 3 goes on the opposite, the 5 goes on the hypotenuse, and in the 4th quadrant, the y value is negative, so there's the negative 3. And so the adjacent side is going to be 4, 3, 4, 5. Then beta is negative 2 over 3. Remember that cosine inverse of a negative input is going to be a 2nd quadrant triangle. And so my beta is going to be in the 2nd quadrant. Beta is the angle, not theta this time. And it says cosine of negative 2 over 3. So the 2 is the adjacent, the 3 is the hypotenuse, and in the 2nd quadrant, your x value is negative, so that's a negative 2. You're going to need to do the Pythagorean theorem here to find the third side. A squared plus negative 2 squared equals c squared. So a squared is 5, And so A is radical 5. And so this side is radical 5. So now that you have your triangles drawn, let's talk about the formula that we're looking for. And here we've got a problem that's asking us for the tangent of alpha plus beta. This is alpha, this is beta, and there's that plus sign in the middle right there that we're looking at. And so that is the tangent, asking you for the tangent of alpha plus beta. So grab your formula sheet, find the tangent of, on your formula sheet it says tangent of A plus B. And the formula for tangent of A plus B is tangent of A, we're going to use alpha, plus tangent of B, we're going to use beta, over 1 minus tangent alpha times tangent beta. Now I'm going to get those values for tangent alpha, tangent beta from the triangles that I drew. Over here for alpha and here for beta. So my substitutions should look like this. Tangent alpha is negative 3 over 4. Tangent of beta is negative radical 5 over 2. And then I'm going to substitute those same values into the denominator. And yes, you have to simplify that. So in the numerator, I am going to multiply the top fraction by 2 so that I have common denominators. And so I end up with negative 3 minus 2 radical 5 over 4, all over 1 minus, and then that negative 3 times negative radical 5 is going to be positive 3 radical 5 over 8, the 4 times the 2. I would accept that as a final answer. It would take a whole lot more time and energy to simplify that, and I just really am most concerned that you can substitute the correct values in the correct places. So in part B, it's nice because you have a negative, or you have a positive input, and so everything's going to be a first quadrant angle. So let's start with just talking about the sine inverse of 7 over 10. Like I said, it's a first quadrant triangle. I can use theta because I only have one angle that I'm talking about, and sine is opposite over hypotenuse. Do the Pythagorean theorem. I'm looking for a squared. 7 squared is, the b squared is 49. And 10 squared, or the hypotenuse squared, is 100. 100 minus 49 is 51. And so A is going to be radical 51. Now, that's an ugly number, but carrying it through the problem, it's actually not so bad. So when you look at your formula sheet, remember here that we're talking about the answer to this is theta. And so this question really is asking us, what is the cosine of 2 theta based on theta in this triangle? Now, when you look at your formula sheet, as I was saying, there are 3 formulas for cosine of 2 theta or cosine of 2a. I really don't care which one you use, and when I say that, I mean that I don't think any one of those 3 formulas is going to be any more difficult or any easier for this particular problem. I think that all three will get you with the same level of difficulty in simplifying to the correct answer. So I personally am going to just choose the cosine squared theta minus sine squared theta. I like the idea of squaring something that's going to have a radical in it so that I can get rid of the radical easily. And in this triangle over here, cosine is radical 51 over 10. Sine is 7 over 10. So I've got radical 51 over 10 squared minus 7 over 10 squared. Radical 51 squared is just 51. 10 squared is 100. 7 squared is 49. 10 squared is 100. 51 minus 49 is 2. And 2 over 100 is 1 over 50. Now, in letter C, again, you're talking about two triangles. You've got, or two angles, I'm sorry, two triangles. You don't really need to draw two triangles for this problem, but two angles. Remember that the inverse functions represent an angle. So you've got your angle represented by inverse sine of 1/2. You also have your angle represented by inverse tangent of -3. But you know the angle that's the answer to inverse sine of 1/2. And so the answer to that one is going to be 30 degrees. So without fussing over anything, let's just call that 30 degrees. And then we'll draw a triangle for the inverse tangent of -3. Input of a negative number into inverse tangent is going to give you a fourth quadrant triangle. And we can call this theta because there's only one angle that we have to worry about drawing a triangle for. Tangent is opposite over adjacent, and in the fourth quadrant, the y value is negative. Pythagorean theorem, 1 squared plus -3 squared equals c squared. So 10 equals c squared. And so radical 10 is equal to c. So over here, now I'm looking at the value of this is theta. And so this problem is asking me what is the sine of 30 degrees plus theta. And so I need to find on my formula sheet the formula for sine of a plus b. And so the formula for the sine of a sum is sine times cos, so sine of 30 times cosine of theta plus cosine times sine. So cos of 30 times sine of theta. Now, I know that the sine of 30 is 1/2, and I know that the cosine of 30 is radical 3 over 2. And now I'm going to use the triangle that I drew up above to find the cosine of theta and the sine of theta. And so looking at that triangle up here, the cosine of theta, and I'll leave those, it doesn't really matter if you do or don't, but I will leave those denominators irrational and write 1 over radical 10 here. Don't forget your plus sign. And by the way, on the previous test, some of you were forgetting to bring your plus sign down. So make sure that you do that. And then the sine of theta is going to be -3 3 over radical 10. And so you've got here 1 over 2 radical 10 minus 3 radical 3 over 2 radical 10. And that whole thing gives you 1 minus 3 radical 3 over 2 radical 10. And you can stop there. Now, just in case you did it where you rationalize the denominators for the cosine and the sine of theta, let me just rework that problem real quick here. So if you rationalize those denominators, you should have 1/2 times radical 10 over 10. Let's say or, for those of you that are just pausing and looking at the answers. 1/2 times radical 10 over 10 plus, we had the radical 3 over 2 times, and then that would be negative 3 radical 10 over 10. You get two fractions with a denominator that's 20. So I have radical 10 over 20 plus, well, it's going to be minus 3 radical 30 over 20. And so that whole thing would give you radical 10 minus 3 radical 30 all over 20. And although there's no rational in the denominator, really those two answers are equivalent. If you type them into a calculator, they would give you the same decimal answer. And again, I don't want you to spend a lot of time trying to simplify. So if you got the first answer that I have in blue, that's perfectly acceptable. And if you went ahead and rationalized your denominators and got the answer I have in green, that would also be acceptable to me. And if you're not sure when you're taking the test, if I want you to simplify a problem farther, just raise your hand and ask, and I'll be happy to say no, stop there, or yeah, you need to do one more thing, and I'll clarify for you. This test is about whether or not you understand the inverses and the composition, and not about whether or not you can simplify. So in this last problem D in this section, your input, notice, is a negative input into inverse cosine, and so your triangle is going to need to be a second quadrant triangle. So over here, I am going to draw for myself a second quadrant triangle. Second quadrant here. And the cosine is adjacent over hypotenuse, and because it's the second quadrant, your x value is negative. Remember that this is a 5, 12, 13 triangle, so that you don't have to do the Pythagorean theorem. Let's call this theta, and the answer to what I highlighted in yellow is theta. And so this problem is asking, what is the tangent of 2 theta? So find that on your formula sheet, and your formula sheet should say that the tangent of 2 theta is 2 tangent of theta all over 1 minus tangent squared of theta. Well, based on this triangle that I just drew, tangent of theta is negative 5/12. And so I'm going to substitute that in here. 2 times negative 5/12 over 1 minus negative 5/12 squared. That gives me negative 10/12 over 1 minus 25 over 144. Now, because we're not dealing with any radicals, I actually would like you to simplify this. So I'm going to leave the 10 over 12 up there for now and deal with the subtraction that's in the denominator. So I'm going to change that 1 to 144 over 144, and 144 minus 25 should be 119. And so I'm going to rewrite that whole fraction as negative 10 over 12 all over 119 over 144. That, remember, if you divide and then change it to multiplying by the reciprocal, you'll get negative 10 over 12 times 144 over 119. The reason that I left that 10 over 12, you don't have to do it that way, but the reason that I left it that way is that I know that 12 goes into 144 12 times, and I don't have to write out the division. And in that case, then you get the answer negative 120 over 119, because that other 12 canceled. So on this last page, we're going to be solving equations. Remember that when you're solving equations, there is no restricted domain and range. So you're looking at the entire space from 0 to 360 or 0 to 2 pi. If you have biggish handwriting, then you're probably going to want to work on separate paper. I'm going to try to fit my answers and my work on this page, and I'm pretty sure that I can do that because I can zoom in and out. So you know who you are. If you need to switch to another paper, please go ahead and do that. But when you hand that in to me, make sure that you give me all your pages and put your names on the separate pages so that I make sure I don't lose anything. So let's start here with letter A. When you see a problem that's fairly straightforward like this, you're going to want to isolate the trig function. And so in this case, that's going to look like getting the cosecant of x by itself. In order to do that, I am going to add 2 to both sides. And so I get radical 3 times cosecant of x equals 2. And then I'll divide both sides by radical 3. And so cosecant of x equals 2 over radical 3. Remember that we learned these values with a rationalized denominator. And so really what you're saying here is cosecant of x equals 2 radical 3 over 3. Now, your answers for all of the problems on this page are going to be an angle, because your input here is, or your x value here is the angle, and you're solving for x, so you need to find out what the value of x is. And so you have one more step to do, and in this case, in the first quadrant, cosecant of 60 is 2 radical 3 over 3. And so your answer to the problem, remember cosecant, is like sine. And so it's going to be positive in the first and the second quadrants. And so your answer is going to be 60 and 120 degrees. And you have to give me both of those angles. In letter B, you want to combine or collect like terms and then isolate your trig function. So I'm looking at the ones that are sine. Again, you can't see what I'm doing with the colors, but I just messed something up. So I'm going to isolate the sines, and I'm going to start by adding 2 sine to both sides. You can do that however you want. So I end up with 5 equals 6 sine of x plus 2. Then I'm going to subtract 2 from both sides so that I get 3 equals 6 sine of x. And then I'm going to divide by 6. So no matter how you did this, you should end up with the sine of x equals 1/2. Sine is positive in the first and second quadrants. Sine of 30 degrees equals 1/2, and we also need to then include sine of 150 degrees equals positive 1/2. Now in number 2, kind of like number 2, in letter C, kind of like in letter B, I want to bring those tangents together, and so I'm going to start by subtracting one tangent from both sides. 2 tangent minus 1 tangent is going to be 1 tangent of x. Bring down the minus radical 3, and tangent minus tangent is 0 here. And when I add radical 3 to both sides, I get tan x equals positive radical 3. Tangent is positive in the first and third quadrants. Tangent of 60 degrees is radical 3, and so is tangent of 240 in the third quadrant, equal to positive radical 3. Letter D, I'm going to add 4 to both sides. So I have 8 sine squared of x equals 4. And so sine squared of x equals 1/2. 4 divided by 8 is 1/2. Take the square root of both sides. You do not have to write that if you don't want to, but you're going to take the square root of both sides. And when you take the square root in order to solve an equation, you want to include both the positive and negative square roots. Now, the square root of 1/2, let me kind of work that out over here. Square root of 1/2 is the square root of 1 over the square root of 2, which is really 1 over the square root of 2. And when I rationalize that denominator, I get radical 2 over just 2. Okay. So all of that here is going to be plus or minus, and then radical 2 over 2. Now, remember that sine is positive in the first and second quadrants and negative in the third and fourth quadrants. And so for problems like this, your answer is going to have is going to have 4 quadrants. So in the first quadrant, sine of 45 is radical 2 over 2. But now you need that 45 degrees and where it's the reference angle in the second and the third and the fourth quadrants. So you're going to have 135, 225, and 315. Now, if you have a multiplication problem that's set equal to 0, you know that you should set both of the factors or both of the things that are being multiplied equal to 0. So in a problem that looks like this, you want to start by saying sine of x equals 0 and secant of x plus 1 equals 0. Sine of x equals 0 is already has the sign isolated. Secant of x equals -1, then to get the secant by itself. Sine of x is 0 when x is 0 degrees and 180 degrees. And again, I would, on the side of my paper, maybe draw my 1s and 0s for sines and cosines and for the related functions so that you have your unit circle intersections here. And you'll see that your y values for sine are 0 and 180. But also remember that when you have 0 as an answer, you should also have 360 as an answer. So those are the answers for your sine x equals 0. But for your secant of x equals -1, remember that secant is the reciprocal of cosine, and cosine is -1 at 180. And so secant of x equals -1 is also 180. Now, you can write that separately, and you can have the 180 appear in your answer twice, and I don't care. Or if you just want to say, look, 180 is an answer, yeah. So if you were to do this problem on a math calculator that can solve trig equations like that, it would only give you 3 answers, 0, 180, and 360, because you're just saying what values of x would make this 0. So you've got 3 answers, 0, 180, and 360. Don't overthink that one. 180 is an answer. For letter F, remember that you cannot divide by a trig function, because a trig function could equal 0 and you can't divide by 0. So in this case, you're going to subtract cosine of x from both sides. So you're going to rewrite this as cos x tan x minus cos x equals 0. And now you should notice that you've got a cosine of x in both terms, and so you're going to factor that out as a GCF. And so that's going to give you cosine of x times tangent of x minus 1 equals 0. And now this problem looks a lot like the problem before it, and you're going to set both cosine of x equal to 0 and tangent x minus 1 equals 0, so that tangent of x equals 1. For cosine of x equals 0, x is equal to 90 degrees and 270 degrees. And for tangent of x equals 1, here goes my clock again, equals 45 degrees and 225 degrees. And I'm just going to keep talking while my clock is striking the hour. Now, in letter G, you're going to want to start letter G the same way you started letter F, by subtracting the tangent from both sides and then factoring out a GCF. So your first step for letter G is going to be 3 tangent cubed of x minus tangent of x equals 0. And then factor out your tangent of x so that you have 3 tangent squared of x minus 1 equals 0 there. And then you have tan x equals 0 and 3 tangent squared minus 1 equals 0. So 3 tangent squared x. Don't forget the x. 3 tangent squared of x equals 1. And then tangent squared of x equals 1/3. And when you rationalize the denominator here, you get tangent of x. Don't forget your plus or minus radical 3/3. So now I'm looking at tangent of x equals 0 and tangent of x equals plus or minus radical 3/3. Tangent of x equals 0 at x equals 0, 180 degrees. And if it's 0, it's also 360 degrees. And then tangent of x equals plus or minus radical 3/3. In the first quadrant, tangent of 30 equals radical 3/3. And so I'm going to have 4 answers for that because of the plus and minus. So I'm going to have 30 degrees, 150 degrees, 210 degrees, and 330 degrees. So yes, this problem has 7 answers. Now in letter H, do you recognize this problem as a quadratic? You have coefficient times something squared minus coefficient times that thing not squared plus a constant term. And so if you want to use your U substitution, here might be a good place to use your U substitution because you want to factor this. And so the thinking for the factoring is going to be 2u squared minus 5u plus 2, and I want to factor that. You can factor however it works to get you to the correct answer. Remember that I like to do my factoring using grouping, so I think 2 times 2 is positive 4. Two numbers that multiply to positive 4 and add to negative 5, that is this number here, are negative 4 and negative 1. Negative 4 times negative 1 is positive 4. Negative 4 plus negative 1 is negative 5. And I replace that negative 5u with negative 4u and negative 1u and bring down the 2u squared plus 2 at the beginning and end. And now I'm going to do grouping. I'm going to take 2 terms at a time and do GCFs of both of those pairs of terms. And so in the first pair, I factor out a 2u, and I'm left with u minus 2. And in the second pair, remember that your sign has to be the sign in the middle of the polynomial. So it's going to be minus 1. And when I factor out a minus 1, I get positive u and minus 2. And remember also that what you get inside the parentheses should be the exact same thing in both times you've taken the GCF. And then for your answer, 2u and the minus 1 are your other binomials. So you get 2u minus 1 times u minus 2. So then go back to the original problem, replace the u's with the cosines that you had in the original problem. So when I factor this function right here, I get 2 times cosine minus 1 times cosine minus 2. All of that equal to 0. Now I'm going to set both factors equal to 0. So 2 cos x minus 1 equals 0, and cos x, I forgot the x again, cos x minus 2 equals 0. Then I'm going to solve both of those. So here I have 2 cos of x equals 1, and cos of x equals 1/2. And then over here I have cosine of x equals 2. So cosine of x is 1/2, where x is equal to 60 degrees, and cosine is positive also in the 4th quadrant, so that's going to be 300 degrees. Over here, there's no angle that would ever make cosine equal to 2, and so just this part of the problem is undefined. And so I'm going to give as my final answer just the 60 and the 300. Now in letter J, I see J as kind of similar to letter B, where I'm going to just collect my like terms for the tangents and isolate the tangent. So I'm going to start by subtracting 3 tan x from both sides. So over here I have 1 tan x minus 7 equals negative 6. Then I'm going to add 7 to both sides. So I get tan x equals positive 1. And tangent of, in the first quadrant, 45 degrees is 1. Tangent is also positive in the third quadrant, and so tangent of 225 degrees is also equal to positive 1. This next problem, this is also a quadratic problem, and so you want to get all of your terms on the same side of the equation, and then you're going to factor. So you're going to say secant squared of x minus secant of x, and then minus 2 equals 0. To factor this, your thinking is u squared minus u minus 2, which gives you u minus 2 times u plus 1. And so I'm going to have secant of x minus 2 times secant of x plus 1 equals 0. Set both of those expressions equal to 0. So secant x minus 2 equals 0. Secant x plus 1 equals 0. So secant of x equals positive 2. Secant of x equals negative 1. And when secant of x is 2, remember that secant is the reciprocal of cosine. So cosine is 1/2 at 60. So secant of x is 2 at 60. And secant is positive in the first and the fourth quadrants. So it's going to be 60 and 300. Secant is the reciprocal of cosine, and cosine is negative 1 at 180, and negative 1 is the reciprocal of itself. And so secant of x is also equal to negative 1 at 180. And so your answers for this problem are 60, 300, and 180. Now, these last couple of problems are going to be a little bit longer. So if you have not yet needed separate paper, because the problems were a little bit shorter, you might need separate paper for the last 4 problems. So in letter M, I am going to, and letter M is the only problem I didn't work out in advance because I changed the problem at the last minute. So my apologies if I trip over what I'm saying. But in letter M, you want to have everything be either sine or cosine. And since I have a Pythagorean identity that says cosine squared, or let's say sine squared plus cosine squared, sine squared plus cosine squared equals 1, and I have sine squared over there, I know that sine squared is equal to 1 minus cosine squared. And so I can go into any equation and replace sine squared x with 1 minus cosine squared x, and that's what I'm going to do for this problem. So my first step here is I am going to rewrite the whole problem with sine squared of x replaced by 1 minus cosine squared of x. So 3 times cosine of x plus 2 times the quantity 1 minus cosine squared equals 3. Now I have to simplify that, and so I'm going to distribute the 2. So I get 3 cos of x plus 2 minus 2 cos squared of x equals 3. And now I want to combine like terms and collect all the terms on the same side of the equation because it's quadratic. And when I do that, I also want to rewrite this whole thing in standard form. So I'm going to bring the minus 2 cosine squared of x out front. I'm going to then add plus 3 cosine of x. And then when I subtract 3 from both sides, I'll have minus 1 equals 0. Now remember that it's tricky to factor a leading coefficient that's negative. So I like to divide out the negative. And so now what I have inside my parentheses is a positive leading coefficient minus 3 cos of x and plus 1. All of that still equal to 0. And now I'm going to factor just what's inside the parentheses. And so my thinking here is 2u squared minus 3u plus 1. I'm zooming in and out because I didn't work this out ahead of time and I need to look at it. So 2 times 1 is 2. Negative 2 times negative 1 is positive 2. Negative 2 plus negative 1 is negative 3. So I'm going to rewrite this as 2u squared minus 2u minus 1u and bring down the plus 1. Notice that this term always equals what these two terms would combine to. So I'm really just deconstructing the middle term. So now I'm going to do grouping. I'm going to do 2 GCFs, the first two terms and the last two terms. And when I do that, I can divide out 2u, and that leaves me with u minus 1, minus 1 times u minus 1. And so I get 2u minus 1 times u minus 1. Now, don't forget to bring down the negative 1. Even though it's not going to change your answer, it's mathematically accurate to do so. And then 2 cos x minus 1 times cos x minus 1 equals 0. So, excuse me, you're going to set, when you set the factors equal to 0, remember that you never include a constant factor. You don't have to set that equal to 0 because it can't equal 0. And so you're only going to do the 2 cos x minus 1 equals 0 and the cos x minus 1 equals 0. So here you get cos x equals positive 1/2, and here you get cos x equals positive 1. Cosine of x is 1/2 at x equals 60 in the first quadrant, and cosine is also positive in the fourth quadrant, so 300 in the fourth quadrant. And then cosine of x equals 1 at 0, but remember that if 0 is your answer, so is 360. And so your 4 answers to this problem are 60, 300, 0, and 360. Now in problem N, I look at this problem and I think, well, I know that I've got a identity that says cotangent squared plus 1 equals cosecant squared. But in that case, both the cotangent and the cosecant are squared, and in this equation, neither of them is squared. But we can fix that situation by squaring both sides of the equation. So I'm going to square this side, and remember you have to FOIL that, and I'm going to square this side. So let me FOIL that off to the side here. So if I have cotangent of x plus radical 3 squared, that's cotangent of x plus radical 3 times cotangent of x plus radical 3. FOIL says multiply your firsts, so I get cotangent squared of x. Multiply your outsides, so that's plus radical 3 times cotangent of x. Multiply your insides, that's again radical 3 times cotangent of x. And then multiply your lasts, radical 3 times radical 3 is just 3. Now, your middle two terms are like terms, and so they can be combined. And so your answer is going to be cotangent squared of x plus 2 radical 3 cotangent of x plus 3. And I'm going to take that expression and write it back over here as the left side of my equation. Cotangent squared of x plus 2 radical 3 cotangent of x plus 3 all equals cosecant squared of x. And then I'm going to change cosecant squared of x to cotangent squared plus 1. That's the identity. Cosecant squared of x equals cotangent squared of x plus 1. I'm going to write the left side, ugly as it is, the same again. Remember that with solving equations, you have to keep writing the side of the equation until you've dealt with it. But now notice that both sides of this equation have a cotangent squared of x without a coefficient, and they're both positive. Therefore, I can subtract cotangent squared of x from both sides, and they end up canceling each other out. And so suddenly this really ugly problem got not so ugly. And so what I have left here is 2 radical 3 times cotangent of x plus 3 equals 1. I'm going to subtract 3 from both sides, so I get 2 radical 3 cotangent of x equals negative 2. I'm going to divide both sides by 2 radical 3, so cotangent of x equals negative 2 over 2 radical 3. And I hope you see that the 2's cancel. And so you end up with cotangent of x equals negative 1 over radical 3, but that's just negative radical 3 over 3. And cotangent in the first quadrant, cotangent of 60 would be radical 3 over 3. And so cotangent is negative in the second and fourth quadrants. And so x is going to equal 120 degrees and 300 degrees. Two more to go. Gosh, I did write small there. My apologies. So for letter P, again, I want to replace sine squared of x with 1 minus cosine squared of x so that I have an equation that's all cosines. And so I'm going to replace that with parentheses here. 1 minus cosine squared of x equals 3 times cosine of x. I'm going to distribute that 2. So now I have 2 minus 2 cos squared of x equals 3 cos of x. I'm going to move the things from the left to the right side of the equation. so that I end up here with 0 equals positive 2 cosine squared of x plus 3 cosine of x minus 2. And so the thinking for the factoring here, if you do u substitution, you've got 2u squared plus 3u minus 2. 2 times negative 2 is negative 4. Negative 4 is positive 4 times negative 1. Positive 3 is positive 4 plus negative 1. And so I've got 2u squared plus 4u minus 1u minus 2. The GCF of the first two terms is going to be 2u times u plus 2. And the GCF of the last two terms is going to be minus 1 times u plus 2. And so my factored form is 2u minus 1 times u plus 2. So I'm going to rewrite that with the cosines back over here. So 0 equals, and then I've got 2 cosine of x minus 1 times cosine of x plus 2. Set each of those factors equal to 0. So 2 cos of x minus 1 equals 0, and cos of x plus 2 equals 0. So in this case, cosine of x is going to equal positive 1/2, and in this case, cosine of x will equal negative 2. Cosine of x is in the first quadrant would be it equals 1/2, would be 60. Cosine is also positive in the fourth quadrant, so that's 300. Cosine of x equals negative 2 is undefined. And so your answer is just x equals 60 and x equals 300. And then for letter R, this is another problem that I'm going to want to square both sides of the equation so that I can use a Pythagorean identity to solve that equation. So when I do that, I get cosecant squared of x equals, now 2 squared is 4 times cotangent squared of x. You can substitute either the cosecant squared or the cotangent squared with the Pythagorean identity in this one, because you've only got one term of each. But I am going to substitute for the cosecant squared just because that's what I have here on my paper. So that's going to be cotangent squared of x plus 1 equals 4 times cotangent squared of x. Then I'm going to subtract 1 cotangent squared from both sides. So 4 minus 1 is 3. So over here I have 3 times cotangent squared of x. Divide both sides by 3. So 1/3 equals cotangent squared of x. Take the square root of both sides, and I've got the plus or minus the radical 1/3 equals cotangent of x. Remember that when you rationalize that denominator, you're going to get radical 3/3. And because it's plus or minus, you're going to have all 4 quadrants represented. In the first quadrant, cotangent of 60 is radical 3/3. And so your answer is going to be 60 degrees, 120 degrees, 240 degrees, and 300 degrees. I think that on this page, zooming out for the whole page is going to be counterproductive because I wrote too small. But let me just try to give you an overview here, and then I'll move up slowly.